Hi everybody, today we're going to do a brief introduction to what we're going to be studying in class this year and also answer the question, what is physics? I'm sure you have a lot of questions. What are we going to be studying? What topics? Do they apply to my real world around me? What goals should I have about what skills I should learn while I'm in physics class? The biggest thing I want you to get out of physics class is to not be intimidated by it. I'm sure you're all thinking there's a lot of math, there's formulas, there's concepts, there's vocabulary. I just want you to understand that physics explains the real world around us. So if you can always think that we're at least trying to explain some phenomenon that you encounter every day, it might make it a little less intimidating. So our objectives for this lesson are to understand why studying physics is useful, to list the disciplines of physics. Physics is a very broad science, and we'll only be introducing a few topics this year. And last but not least, in order to answer that question, what is physics? We need to be able to define matter and energy and their relationship to physics. All right, so if you open up your textbook or any other science textbook or a dictionary and look up the word physics, you might see a definition similar to this one. Physics is the branch of science which studies matter and energy and how they are related. That's a very broad definition. As a matter of fact, I bet if I asked each of you to put it in your own words, each of you would probably come up with a different definition. So I'm going to give you my definition. I like to think of physics as the science that answers those why questions that we have every day. Even those why questions that we had as soon as we could talk. Why is the sky blue? Why is the grass green? Why does that ball bounce up and then come back down again? Why does mommy's voice sound the way it sounds and daddy's voice sounds the way it sounds? All those simple type of questions can be answered with physics. Now in class, some of our questions may be a little bit more sophisticated than those. If you play a sport, you may have noticed that if you play tennis or you play basketball or you play soccer, that as you move the ball from one person to another, the ball moves through the air in a very particular shape. We can answer why the ball moves through the air in that shape, that arc shaped, using physics. If you went to an amusement park over the summer and you rode a roller coaster where you were turned upside down and hopefully didn't fall out of your seat, we can answer the question with physics as to why you didn't fall out of your seat. If you go home today and you plug in your iPhone or your iPad and you want to recharge it, or you plug in any appliance, you want some microwave macaroni and cheese as a snack, how did that energy get from its source to your outlet, and how does it move through your device in order to make it turn on? If you're an eyeglass wearer or a contact lens wearer, how did just a simple piece of glass fix my vision? So all of these questions are the questions that we should be able to answer through the years we study physics. So now, before we go a little further about answering what is physics and what we'll be studying, we really need to make sure that we define those words, matter and energy. Because remember, we never want to define a word with words that we don't understand. So matter. Hopefully you remember from chemistry class or any introductory science class you had in middle school that matter is any material that has mass and takes up space. It can be a solid, it can be a liquid, it can be a gas. It can be small as an electron, it can be as big as a planet. What I want you to realize is through most of the year, we're going to be covering real world matter, things that we can touch and feel. Basketballs, footballs, people, bicycles, cars, planes, all those things that we really do encounter in our everyday lives. Energy. Now the definition here for energy says the ability to cause changes in factors like temperature, height, or speed of matter. So if you take, for example, the block, right? Its height has changed, its position has changed. If you look at this liquid here, the thermometer is indicating a change in the temperature of the matter. Energy is associated with things like temperature, height, or speed of matter. So if you look in your textbook, you'll probably see a definition for energy that says something like the ability to do work. And because work for us is that ability to transfer energy from one type to another or from one matter to another. So when we start looking at that relationship of energy, we start looking also about work, and it's all about how do we transfer the energy to change the energy of one object or to get that energy from one object to another. All right, so you might remember from chemistry too that there's a lot of different types of energy. We will not cover all of them in class. From chemistry, you may have talked about thermal energy, the energy associated with an object or matter because of its temperature. You might have talked about chemical energy, that energy that is released as a result of a chemical reaction. We're not going to be talking about those. Most of the year, we're going to focus on this guy right here, mechanical energy. The energy having to do with real-world objects, and the energy that has to do with the position or the motion of those real-world objects. And that's why we talk about things like footballs and cars and people and airplanes. They're real-world objects that change their position as they move. In the second half of the year, we're going to start going back to some of those types of energies that are involved sort of at the lower than real world size matter objects, and that would be electrical energy. How do we get electricity from point A to point B? How does the objects in our house use that electricity? And then we'll talk about electromechanical energy, or excuse me, electromagnetic energy. That would be what we talk about as far as visible light, anything that's in our electromagnetic spectrum, radio waves, X-rays, UV rays, all those types are part of the electromagnetic spectrum and part of the electromagnetic energy that we get from the sun. When you look over here and you see the sun and some things that are about nuclear energy, that's a topic that we won't be covering. I don't think we'll have time. Most of that energy is covered in modern physics. And when you talk about modern physics, you talk about the 20th century and beyond, the period of Einstein and beyond. What we'll be talking about through most of the year is called classical or Newtonian physics, so that pre-turn of the century or the pre-turn of the 20th century. All right, so what type of topics will we be talking about? As I said, first half of the year we'll be studying mechanical energy. So the topics that we will be studying are considered mechanics. The motion of objects, why those objects move, how their energy changes as their motion changes. After we're finished up with mechanics, we'll go into electromagnetism. So we'll start talking about electricity, magnetism, and light. After we're finished up with that, we're going to go into a whole big topic here where we talk about vibrations, wave, and optics. So we're going to talk about another way of transferring energy via waves. And when we start talking about that, we talk about things like sound and light. So why we hear the things that we hear, how we hear them the way that we hear them, and then optics, how we can take that electromagnetic energy that we see as visible light and maybe change the way we see things using mirrors or lenses, or describe the way we see things talking about color. All right, the topics that we won't cover are thermodynamics. Thermodynamics is that study of heat and temperature. We might talk a little bit about heat when we talk about things moving over or rubbing up against one another and they warm up, but we won't be covering the science of thermodynamics. And these two down here, relativity and quantum mechanics, again, they are part of that 20th century modern physics or around Einstein era, where we start talking about the energy that we can find in subatomic particles. All right, so some of those you may look as topics and figure they're not really going to apply to your real life, but in reality they just might. Looking at some of the careers or some of the colleges or topics that I see that you like to study on my Getting to Know You, maybe we don't have a whole lot of engineers out there, but engineers are problem solvers. So if you're solving a problem, the fact of the matter is you're acting like an engineer. So a lot of the things in simple mechanics that we talk about in class are things that there are engineering principles. How do you get that soccer ball to go to the place that you want it to go? You may not think that you're being an engineer when you're doing that, but you're solving a problem. And even if it's just instinctual or because of practice, you are actually practicing some type of engineering in there. Business and finance. Business and finance, as you even look at the perspective of energy, Business and finance usually has to do with commerce, building objects, transporting objects, selling objects. How do we price those objects based on the cost that it takes us to build them and transport them and get them to our consumer? All right, so business and finance, again, a lot of science and physics in there. Medical technology. If you are thinking of becoming a nurse, a physical therapist, an occupational therapist, and I saw a lot of those on my Getting to Know You forms, you think about the technicians, even reading x-rays, reading sonograms, looking at MRIs. All of those diagnostic tools use physics. Even if you think about if you want to become a physical therapist, the fact that somebody has to exercise and lift weights and move their body, that's motion, that's physics. So even if you think you might not be taking a physics class in college because of your career, you'd be surprised where it might be hidden. And even for our art people out there, music and art. If you think about musical instruments, and we have some wonderful musical performers at school, the instruments that they play, how do they play them so that they sound so wonderful? Why do they sound so wonderful? Why do instruments sound differently? Different types of instruments, they have different sounds. If you are an art person, a fashion design, colors, textures, all those things that we see that you are probably so talented at incorporating into drawings and fabric, all of those come because we see light and we see color. That all can be described with physics. Right? So when you think about that, there's a lot of why questions and a lot of how questions in there. So what you want to remember is when you talk about physics and we talk about our real world, it's all about inquiry and observation. Why, how, and then the because coming out of the observation. So even if you look at this as your scientific method that you may have learned, the scientific method is just a series of common sense steps that you need to do when you want to find out a reason of why something happens. So you ask a question, even if it's as simple as, why doesn't my car start? There's your question. Well, your first hypothesis may be, well, maybe the battery's dead. Let me go out and check. Will my lights turn on? Can't be the battery, otherwise those lights wouldn't turn on. Let me go back and reevaluate my hypothesis, collect some different data, come to a different conclusion. It's all about inquiry and observation. And fortunately for us, a lot of the inquiry and observation has been done by people before us that have asked those exact same why questions. And they've gone out and they've done the observation for us, and they've come up with the theories and the laws that we're going to study as we go throughout the year. But we just want to make sure as you go through the year, please do not stop asking those why questions. All you're trying to do in this class is understand the world around you.